Hello guys, today we're going to talk about encapsulation, one of the three main pillars of object-oriented programming. So let's illustrate this concept with an example. We'll create a class that we call account, and of course we want to give this account a balance. So we'll think about a variable like double balance. And now we have to ask ourselves, well, what kind of visibility do we want to give to this variable? The simplest choice, the simplest of the choices would be to make the variable public. What are the consequences of this choice? Well, if you go in another package and we create another class, and we'll call this class main, and we'll ask Eclipse to generate a main method, then we can see that when we create an account A equals new account, when we create this new account, then we have a visibility. Of course, we have to import the account class since it is in another package. Then we can see that the variable is visible, the variable balance, which is of course public, is visible, and I can modify it or I can read it to my heart's content. So a dot balance. So you see that I can both write to this variable and I can read the value of the balance variable inside my account. So now you see, oh, that's great. It's very easy to do, very simple. It's all very straightforward. But actually, this is not the best way to proceed. And having the balance variable public is a very bad idea. Let's try to understand why. The recommendation is actually to have this variable as private, and to expose it to other classes, if necessary, with a couple of methods that are called getter and setter methods. And let me just use Eclipse to generate these methods for me. So let's go to right-click, source, generate getters and setters, and we'll ask to have both a getter and a setter method for the variable balance. And now I'll also press Ctrl Shift F to format my code automatically. We all know that we programmers, we all like to have our code formatted beautifully. And well, let's go back to our main class, and we'll see now that the compiler is complaining that my balance variable is not visible. So of course we know that a balance variable exists, but we cannot reference it so freely as we did before because it's not public. And now that it's private, the balance variable is visible only inside the class that defines it. So if we want to modify the variable, what we have to do is to use the setter method and say a dot set balance and give it whatever value we desire. And if we want to read the value of our balance, of course you already know what we're going to do. We are going to call the getter method. So a dot get balance. And so we are back in a situation where our code compiles, but it just seems more complicated than we had before. And we're actually doing the same things that we were doing before. So how is this better than having the variable public? Because it just seems more complicated. Well, the thing is, you might be led to believe that from the keyword private that this is actually a matter of privacy or security or wanting to hide some information from other class for confidentiality reasons, but actually that's not the case. The meaning of this keyword variable is all about software engineering, not about privacy. And the reason that the balance should be private is that if it is public, then external code will start using that variable, and then I cannot change it anymore. That's the fundamental reason that stands behind this encapsulation principle. The public interface of a class, that is, the public functions and public variable, are actually what is known from other classes about our class, and so what is directly used. And what is directly used cannot be, by other classes, cannot be changed unless we want to break those other classes. So let's say that, for example, in a new iteration of our software, we want to get rid of this private double balance, of this variable balance. Why? Well, let's just imagine that for some reason, we prefer reading it directly from a database. Maybe we have this new method, read from database, that we want to use. And let's have Eclipse generate these methods for us. Create method, and note that Eclipse by default generates this method as private. And let's just leave it as it is for now. It's only for illustration purposes. And let's say that also, of course, setBalance cannot assign to the balance variable anymore because this variable does not exist. Let's say that we want to call this other method. Let's call write to database. There we go. If I can spell it right. Write to database, and let's generate this other method as well. Thank you, Eclipse. And so, for us, it's vital, it's very important to be able to make this extension to our class account, to make it more efficient, or for whatever other reason. And let's go back to the client code of our class. And please notice that if you were using accessor methods like setBalance and getBalance, well, this code is not aware at all of the change that has occurred inside my account class, even though this change has been quite radical. We have eliminated one variable, we have a totally different strategy of data access, but the client code doesn't even realize that. And why is this good? Well, of course, it's obvious, because so it's not broken. It doesn't have to change as well. Internal changes to the implementation of my class do not ripple to other region of my software or to other software that's using my class in the same way that it would have done if my balance variable had been public. Then, of course, I could not have changed the named type of this variable, and I couldn't have decided to eliminate it. So I hope you understand now the main reason behind this practice of having variable as private and expose them if necessary. Let me stress this point. It's not always necessary to expose a variable with the getter and setter methods. Some programmers tend to do that automatically, but actually also this is a very bad practice. If you can design our software in a way that even the getter and setter methods are not necessary, then the robustness of my class is even improved. But if we have to give access to the outside world, to the value of the balance, of course, yes, we can go ahead and create getter and setter method, but please never use public variable unless, of course, you are in the case of the classic exception that confirms the rule. So another side advantage that we have when we use getter and setter methods is actually that we can modify, for example, setter methods to, let me just press Control and click to go to the setter method. And of course, we can make modification to our balance. Let's say, let's use a guard condition that doesn't allow negative balances. So we could say if balance is less than 0, then we could throw an exception, or we would do something else, else we can actually proceed and write the variable to my database. Let's just make a comment to remind ourselves that we still have to decide what to do with the negative balance. And yes, this is useful. It's very useful that we can modify our software and put in their condition or other kind of strategies. But the main reason, this is actually cited sometimes as the main reason for using getter and setter methods. But actually, the main reason is more general. This is just one of the many subcases of the main reason. The main reason is that now that my variable is private and protected from outside and visible only through a couple of methods, then I can modify it as much as I want. I can eliminate it, I can put guard conditions, I can change its type, I can do whatever I want with it. And I can do that without breaking the software that I use in my class. So now I hope that you understand the deep reason behind the practice of encapsulation. You understand not only what encapsulation is, but why it's useful and why it's such an important concept in object-oriented programming. Because object-oriented programming is all about extensibility, is all about the open-close principle. It's all about having our software being open for extension but closed for modification of already existing code. And thanks to encapsulation, we have seen that we can extend and change the functionality of the internal implementation of our class without having these changes force us to change our other code that was used in our class before our modification. In our next lesson, we talk about the second pillar of object-oriented programming, that is inheritance.